Hello friends, this is Durga from IT University. As part of this video, under CCA Spark and Hadoop Developer playlist, I'll be talking about ingesting real-time and near real-time or NRT streaming data into HDFS using Flume. This comes under the first module, data ingest, and so far we have seen how to ingest data from a relational database such as MySQL into HDFS using Scoop, and also export data from HDFS into a MySQL database using Scoop. And then we have seen some advanced features of Scoop, and in this video we will be introducing a new technology called Flume to understand how to integrate data in real time and near real time into HDFS. For that, we need to first understand the Flume architecture. We should understand how to configure Flume to get data into HDFS in real time or near real time, and also um, uh, we should understand the shortcomings and how we can work around those shortcomings while ingesting data in real time or near real time. For the documentation, you can scroll down and click on Apache Flume 1.5.0 documentation. That is the version which they will provide at the time of certification. And here, if you scroll down, there are three Flume documentations. One is user guide, other one is developer guide, and third one is Java docs. Developer guide and Java docs are primarily for those people who actually work on Flume development from the open source community. So as a user of Flume, to integrate data in real time or near real time, you need not worry about developer guide or Java docs unless you want to make some custom changes to the tool itself, which is not within the scope of certification. Only thing you need to be familiar with is Flume user guide, and this is the documentation which you need to worry. And also for certification, you can use the Cloudera VM. The way we have used Scoop, Flume is already there on this VM, and you can start practicing on it. They will not ask you to set up Flume at the time of the certification. You just need to understand how you can configure Flume to get data in real time. So now we will see the Flume architecture, and before looking into the Flume architecture, let's understand the purpose of the Flume itself, and then we will see the Flume architecture. I am going to whiteboard now. So here is our HDFS cluster. It could be many nodes. In our case, it's a single node Cloudera VM, but typically you will have HDFS cluster with many nodes, and there will be multiple sources. And then open systems. This is database. There will be open systems as well, and there could be mainframes. This is mainframes. So integrating data from mainframes into HDFS is out of the scope. No need to worry much about this, but you should be able to get the data from databases into HDFS. And for that, one of the tool is Scoop, which can connect database directly and load into HDFS. And then there are other sources also from which you need to integrate the data. Under open systems, again we can categorize into multiple systems. One can be something like third-party third-party systems which will push the data onto your file server. Typically a file server will be there in between, so they will push the data onto the file server, and from the file server you will put the data into HDFS. And also there can be weblogs itself. For example, if you are running a web application, it will log a lot of information into the weblogs. Sometimes you need to capture that information and directly push it into the target systems like HDFS or Hadoop. And for that you cannot use tools like Scoop. Instead, you need to use tools like Flume, Kafka, Storm, etc. So Flume is primarily to pull the data from open systems, via weblogs, and then integrate it into HDFS. So for that, on the source system, you need to have a Flume agent which can poll the weblogs. So it should know where the weblogs are. It will poll those weblogs on regular basis, and then it will channel the data. So you will have a channel, and then it will push the data from it will channel the data which is collected on source by the agent to an agent on the target system. So that's the architecture of the Flume. You will have an agent on the open system, and also you will have an agent on the gateway node of our Hadoop cluster. So there will be a gateway node for Hadoop cluster which will have all the Hadoop binaries and parameter files pointing to a particular Hadoop cluster. An agent will be running on that gateway node, and that understands where the HDFS cluster is, and that will actually load data into the HDFS. So this layer, which can pull the data from weblogs and channel through Flume agents and push data into HDFS, can be implemented using Flume agents on source and target systems. So if you go back to the documentation, this explains that. So you have a Flume agent, one agent on the somewhere. It could be on the web server itself, it could be on a separate node on which only Flume is running, or it could be on the gateway node. And so the source, from the source system, it will be polling and pulling the data, and it will be there can be multiple channels like this, and a sink can be another Flume agent, or it could be HDFS, or it could be anything. So this is the typical architecture. There can be multiple Flume agents which will have source, channel, and sink, and the source can be a Flume agent or web server or anything. And then you can have multiple channels from one source pointing to multiple sinks. Again, a sink can be a Flume agent or a Hadoop cluster or anything. So that's why they created a separate layer of Flume agent. A Flume agent can be running on the source system, can be running on a separate server, and can be running on the gateway node, and there can be multiple Flume agents in between to get the data from the source to the HDFS. If you scroll down, there might be few more architectures also. If you see, this is a setting multiple agent flow. We are getting data from a source. A source can be anything, but the sink is another Flume agent here. And then from the second agent, the sink can be anything. For the second Flume agent, the source is Flume agent itself, and here this is actually converting data to Euro format and pushing it into the second Flume agent, and then that Flume agent is pushing to whatever target it is specifying. And this is called as consolidation architecture. You have multiple web servers, you have multiple Flume agents, agent 1, agent 2, agent 3, and then you are pushing data from all three of these agents into the fourth agent, on where data is being consolidated and pushing into HDFS. As you see here, there are 4 agents, but that doesn't mean that you need to have 4 installations of Flume. You can have one Flume installation itself. And this one is within the one Flume agent, you are channelizing data to multiple sinks. One could be HDFS, and the other one could be JMS, and the other one could be Flume agent. So you can visualize all the different use cases how you can implement using Flume, and then you can decide how to set up the configuration. Okay, these are the three main architectures of Flume using which you can integrate the data. First one is multiple agents, second one is consolidation, and the third one is multiplexing the flow, wherein from one source you can channelize to multiple sinks before loading into HDFS. That being said, let's see what is there on the quick start VM. You can check the Flume version, I think with this command, flume-ng, yeah. Flume-ng is the command which you need to use. It's just flume -ng version. So this is 1.5.0, so you can safely use this VM for the practice of our certification. And then you can go to cd/opt/examples ls-ltr. There will be a directory called Flume. ITversity is created by me for the demonstration, so you will not find this on your VMs, but you will find the directory called Flume here, and you can ls-ltr, and Morphlines is the tool which is provided by Cloudera to actually generate test data simulating the web logs. And then you have the configuration directory. You can go to cd conf ls-ltr, and you can see a sample flume env.sh and flume.conf to actually understand how the Flume agent is configured. If you see here, so this is the agent name. There is no parameter which will tell you the agent name. The first, so each agent have different sets of parameters. One is for one set of parameters are for sources, other set of parameters are for sinks, and other sets of parameters are for channels. When you are using these set of parameters, whatever the first word is, that will be the agent name. Here if I say ITversity, the agent name will be ITversity itself. So whatever agent name you want to give for a particular agent, you just have to start with that one for your source, for your channel, and for your sink. Okay, and each agent has to have all these parameters. So in this example, what it is doing is the source is access.log file. So it is actually reading data from this log file by running this tail -f command. This is the Linux command. So it will periodically run this on that file, and it will read the data, and then it will channelize the data. So while channelizing, it will build as per the configurations. In this case, capacity of the channel is 20,000. So until it has 20,000 entries, it will channelize through, it will build the pool of the data before pushing it to sink. So once those channel thresholds are reached, the data will be pushed to sink, and then based upon what you have done at the sink, it will take the necessary action. In this case, the sink is configured to push data into Solr, which we will not be using. Solr is not within the scope of the certification. As part of the subsequent videos, we will build our agents in such a way that it pull the data from the logs and push into HDFS, not the Solr. But this is just a sample, and I want to show how it look like. Okay, and also another very important resource is this one, Cloudera Flume exercise. To get to this, you can say google.com Cloudera Flume exercise and hit enter, and this is the one which you need to worry. Okay, and it will tell you how to do the Flume exercise on the VM. it's another important resource, and I will be using this one and customizing it for our certification to demonstrate how we can get the data from the weblog and integrate into HDFS. Okay, that being said, this is just an introduction about Flume. I have explained the Flume architecture, the resources you have in the Cloudera Quick Start VM, and the Cloudera itself, like this one. In the subsequent videos, we will play with Flume, probably 2-3 videos. I will try to wrap it up. That being said, if you like this video, please click on the like button. If you want to provide the feedback, please use the comment section of the video. If you have any technical questions, please go to Stack Overflow and tag appropriately. And if you want to discuss on these topics, especially from the certification perspective, you can join my LinkedIn group called IT Varsity Hadoop Certifications. And if you have not subscribed to my channel yet, please do so. You will get to see a lot more content like this over time. Thank you. Bye.